Hello, and thank you for taking the time to watch this video on motor and generator high voltage testing. My name is Ali Al-Shari, and I'm an international sales engineer at Hipotronics, the leading manufacturer of high voltage testing systems. Today, we will be talking about motor and generator high voltage testing. Before we get started, if you have any questions regarding this presentation, please don't hesitate to reach out to us at sales@hipotronics.com. We will be happy to answer any questions you may have. Now, without further ado, we will go over the agenda for this presentation. Today, we'll be talking about basic definition for electric motors and generators, what are the industrial uses, the applicable high voltage tests and affiliated standards for motors and generator testing, going over DC Hipot testing, AC Hipot testing, insulation resistance and polarization index testing, and performance test. We will go over what Hipotronics equipment we offer for high voltage testing on motors and generators, starting with the 800 BL series, the 700 DI series, the TSR, and the MTS. Starting with the basic definitions for motors and generators. A generator converts mechanical energy into electrical energy, while a motor does the opposite. It converts electrical energy into mechanical energy. The applications for electrical motors mainly include blowers, fans, machine tools, pumps, and turbines, while generators can be seen in power stations to generate electricity. For every motor and generator, there are two essential components, the stator and the rotor. The stator is the stationary part, as the name suggested. In contrast, the rotor is the rotating part. Both stator and rotors are covered in insulation that prevents short between winding, as well as from the conductors to the grounded frame. Moving to the applicable tests and standards, we will be first looking at the DC Hipot and DC Hipot testing. The DC Hipot tests are modeled after AC Hipot tests. Thus, a DC Hipot test voltage is often derived from a typical AC Hipot test voltage, which is proven to work well. The AC and DC Hipot tests follow the following standards: the IEEE 95, 112, and 114, IEC 634, ESA AR 100, and NEMA MG1. It's a 1-minute test unless the specified test voltage of the unit is less than 2500 volt. A 1-second test at a 1.2 times the specified 1-minute test is allowed. The two tables on the right shows the test voltages for new machines and used machines as per the standards. Moving to the IR and PI test, the insulation resistance and polarization index test of an electric motor or generator have been regarded as a useful tool in evaluating its winding for the buildup of dirt or moisture or deterioration of the insulation. The IEEE standard number 43 covers the procedure for determining insulation resistance and polarization index in details. The insulation resistance reading are taken after the test voltage has been applied for 1 minute. At the same time, the polarization index is the ratio of 10-minute insulation resistance test to the 1-minute insulation resistance test. It's common to take reading at 1 minute, 1.5 minutes, 2 minutes, 3 minutes, up to 10 minutes. Table 1 on the right shows the guideline for direct voltage to be applied during the insulation resistance test, while Table 3 shows the recommended minimum values of polarization index for insulation per thermal class machine components. Different efficiency tests are called by different standards like the IEEE 95, 112, and 114, the IEC 634, ECIR 100, and NEMA MG1. Tests like the no-load test, which is the same as the open circuit test performed on transformers, vibration test, sound level test. On the right hand, figure 7-6 or -6 shows the machine vibration limit from standard industrial motors to precision motors with special requirements. As it can be seen on the right diagram, the connections are made to the stator. This is often done in a gang test where the three phases are tied together. This will allow to find the faults between the stator windings and the grounded frame. For this test, the rotor may be in place or removed. The DC test is the same connection as the AC test. Once the test is completed, the winding under test have to be discharged. Moving to the PI and a DAR test. The PI, or polarization index, is a metric used to determine the health of insulation of four-mode motors and generators. PI is the ratio of the megaohms after 10 minutes divided by the megaohms after 1 minute. A ratio of 2:1 is the minimum recommended for suitability for the surface or implementation of Hipot testing. Any values below 2:1 should be concerning. On the other hand, the dielectric absorption ratio is another metric for determining the insulation health. It's the ratio for megaohms at 1 minute divided by the megaohms at 30 seconds. When the measured leakage current stabilizes within 1 minute, operators usually use the DAR test. If this happens, the 10 minutes PI test is useless because the ratio is 1. Values for DAR and PI used for evaluating the insulation conditions are anything less than 1.25 DAR value, the insulation condition is questionable. For any DAR that's between 1.25 and 1.6, the insulation condition considered good. For any DAR value over 1.6, this is an excellent insulation condition. On the other hand, for any PI value between 1 and 2, it's a questionable insulation condition. 2 to 4 PI values, the insulation condition is good. Any PI value over 4, you have an excellent insulation condition. After discussing the applicable high voltage tests and affiliated standards, we now shift to what Hipotronics offer for motors and generator testing. Starting with our 800VL series, the DC Hipot for motor and generator is very common for two major reasons. First, the capacitance of motor and generators can be difficult to determine, because more capacitance means greater current draw. In other words, it could pull more current than an AC Hipot unit can supply. Also, DC Hipot system can test any size load. The second reason is that because the DC Hipot is much smaller in size and lighter in weight compared to other AC Hipots, which make it easier to transport to remote locations. Our 800VL series is ideal for testing large motors and generators that have very large capacitance because of the robust grounding scheme and the automatic quick DRAM feature for safe discharging. The 800VL series come with multiple safety features for very safe operation, such as an e-stop on the front panel. Hand switch, foot switch interlock options are also available. Safety strobe option to alert operators of high voltage. The 800PL series can also automatically calculate the PI. Another great feature is the programmable automatic mode, which allows user to create their Hipot step voltage testing program. For AC Hipot testing, our 700-DI series can provide enough current to test most motors and all but the largest generators. Some of the great features the series offer: it can perform AC Hipot testing from 5 kV to 400 kV and up to 300 kVA. It comes with high accuracy with plus and minus 1.5% of reading and plus and minus 0.2% of full scale. The series can operate from 0.5 to 100% of the rated output voltage. The 700-DI offers programmable test procedures, and it can be possible to integrate it into almost any lab or production facilities. The series can be controllable via onboard touchscreen controller or a PC software or remote commands. The 700-DI series offer automatic digital data acquisition for easier collecting, storing, and saving data. The 700-DI is also Safety Integrity Level 3 compatible. The 700-DI series also offer great low noise high voltage source for partial discharge measurement, with the optional item for an output level of less than 2 PC. The series also can be integrated into 10 delta measurement systems, and the continuous duty cycle option is available. The series also offers mobility option for mobile testing, and the galvanic isolation option is also available for the 700-DI series. Moving to our resonant test systems, the TSR, our tank type series resonant test systems, which can be used for applied AC test on generator windings and can be built into a single enclosure to maximize portability in the factory or on the site. The TSR is used for large capacitive loads in microfarads range. The TSR can test full assembled windings, and it can utilize energy storage properties, higher voltage and current output versus input. The TSR can come with lower Q factor versus resonant test systems used in other applications due to the losses in the circuit when testing generators. Some of the unique features the TSR offer are the following: all-in-one cabinet closure. Like seen on the picture on the right, the cabinet includes the regulating transformer, the exciter transformer, the high voltage reactors, and the required capacitors and base loads. Other features like series or parallel resonant operations, oil contaminant provisions, thermal protections, and vibration damping provisions. On this slide, we can see some of the typical generator ratings. For voltages, it can be seen from 230 volt up to 15 kV, with winding capacitance between 300 nanofarad to 4 microfarad. For the AC test voltage, it should be 2 multiplied by the nameplate voltage plus 1000 volt, where the current can be calculated as 2 multiplied by pi, multiplied by the frequency, multiplied by the device and their testing capacitance, multiplied by the test voltage. On this slide, we can see some of the TSR models Hipotronics offer. Other voltages and current ratings are also available based on the customer testing requirements. Another great solution we offer here in Hipotronics is the motor test systems. The MTS is an electrical control, measurement, and power device used to start up multi-horsepower single-phase, polyphase, and DC motors. The MTS measures electrical and physical parameters while the motor is running at a determined RPM. On this slide, we can see the 4 different motor types, starting with the AC induction, where the stator winding is energized from an AC source. If the load increases, the speed decreases. The second type is the AC synchronous, where the armature winding is energized from an AC source and its field winding from a DC source. It always runs at a synchronous speed independent of the load. The third type is the AC traction. With a variable frequency drive, it adjusts speed by changing frequency. The last type is the DC motors with series and shunt wound. Series is always better for high torque applications, where the shunt is better for precise speed control. On this slide, we can see the efficiency test Hipotronics MTS system can perform. They can run motors to their nameplate value. The MTS can measure line-to-line voltage and current, watts, temperature, power factor, RPM, and vibration. The table here shows the technical specifications for some of our standard MTS systems. The model prefix MTC applies to systems with both AC and DC testing capabilities. Motor test systems with AC capabilities only, the DC specifications in the gray shaded area is eliminated, and model prefix changes to MTA. Larger and smaller units may be available upon request. Our MTS comes with the following unique features. Using PVT, you will have a pure sine wave over the entire range of outputs. A remote control comes as a standard feature. It also offers duty cycles designed to meet motor testing requirements. After talking about some of the systems and solutions we offer here in Hipotronics for motor and generator testing, we will be now looking for some common questions on Hipot testing. The first question is, does Hipot testing damage a good winding? The answer is no. Maintenance, Hipot tests do not introduce any significant degradation in a machine with a good insulation. The second question is when to apply a Hipot test. The answer is Hipot test should be used as an acceptance and quality assurance test on new winding. Maintenance program should include Hipot test and should be tested every 3 to 6 years. The third question is what test should we consider, AC or DC Hipot? The answer is AC Hipot tests are preferred for new machines, but either Hipot test is better than no Hipot test. In conclusion, high voltage testing can tell you a lot about a generator or motor's condition and integrity. The most common test that manufacturers and service groups must do is a high voltage AC dielectric withstand test. The test involves applying an AC voltage to a rotor or stator winding to verify it can withstand a specified AC voltage. This will not only confirm the quality of the new generator or motor, but it is also a useful test to verify the insulation condition after a generator or motor has already been installed. Although AC dielectric testing is a common high voltage test performed, there are many other tests done for quality checks and preventive maintenance purposes. These other high voltage tests include power factor testing, insulation resistance, no load and load testing, and of course, the DC Hipot testing. Here in Hipotronics, we offer the largest variety of generator and motor testing equipment on the market. Hipotronics can provide the necessary high-voltage test equipment to all generator and motor manufacturers, service and maintenance companies, and those in the hydro and mining industry where generators and motors are used frequently. At the end of this presentation, I want to thank you for your time and encourage you to reach out to us if you have any questions or if you need more information about any of our systems. Our contact information are listed below. Thank you.